morning friends. After the discussion of the measurement of the surface tension, we are going to discuss about that the pressure difference in case of an air bubble or the drop of a liquid, or whatever the air bubble formed inside the liquid. First the question arises in our mind that why the liquid drop always in spherical shape, but the air bubble is also always in spherical shape. What is the reason? So first thing, why the small drop of liquid are spherical in shape? So here the two reasons. One reason is that a liquid air interface has the energy. So far, a given volume of the surface with the minimum energy is the one with the least area. What it says that each and every surface has the tendency to minimize its surface, that means to minimize its surface energy. Out of all the shape, only the spherical shape has the minimum area. And due to that reason, the liquid drops are spherical in shape. Again, any surface has the tendency to minimize its surface energy. To minimize the surface energy, the surface must be minimized. Out of all the shape, only the spherical surface has the minimum area. And due to that reason, the liquid drops of liquid always in spherical shape. Second thing is that in a spherical shape, now listen, as we consider the sphere, inside is the material of a sphere, outside is air particles or the air is present. Therefore, the two types of the forces are exerted on the surface. One is each and every particle of the material lying on this surface apply the force of attraction on the inside molecule or the inside particle of the sphere. Here, the force of attraction between the molecule or the atom of the same material, that is the cohesive force. While outside the air medium is present, molecule of the air medium also apply the force of attraction on each particle of the molecule or the particle of the material on its surface. But here, the force of attraction between the molecule of two different materials, so that is the adhesive force. That is the adhesive force. So we know that the cohesive force is more stronger than the adhesive force. Cohesive force is more stronger than the adhesive force. Therefore, the force exerted by the inside molecule on the surface of a sphere is more compared to the outside force. And due to that reason, the shape of the liquid drop or the air bubble is always in spherical shape. Now, moreover, the adhesive force between the molecule of the liquid and air is less than the value of the cohesive force. The adhesive force is less than the value of cohesive force between the molecule of the same material. Right? So, drop of liquid are spherical in shape. Here the force inside is more compared to the outside force. Fi is more than the Fo. Therefore, the inside pressure is greater than the outside pressure. Inside pressure is always greater than the outside pressure. Therefore, in case of an air bubble or the liquid drop, there is the tendency to expand its volume because the inside pressure is much more compared to the outside pressure. Because the inside force is much stronger or the much more than the outside adhesive force, and due to that reason, the drop of a liquid or the air bubble always is spherical shape. Clear this? On the base of this, we are going to discuss about what is the pressure difference between the inside and outside surface of a drop or the air bubble. Right? So in short, the force acting on the concave surfaces is much more compared to the convex surface. Convex surface. Okay. On the base of this, we are going to discuss about the pressure difference, or we are going to derive the expression for excess pressure for a drop and air bubble. So this is the most important question. Most important question. This question is asked in three different manners. One is derive equation for excess pressure for drop or the air bubble, or obtain pressure difference Pi minus Pu. Pi is the inside pressure, Pu is the outside pressure, is force upon R for an air bubble formed in a medium. Or this question is also asked like this manner. The pressure difference Pi minus Pu is equal to 2S upon R for a liquid drop or the air bubble formed inside the liquid. Why the both equations are different? So one result is that whatever the air bubble formed in a medium, it has the two free surfaces. Inside is A, outside is also A. What is the free surface? Whatever the surface of a liquid is directly in contact with the air medium, that is known as the free surface. For the air bubble formed in a medium, inside and outside both are A medium, therefore it has the two free surfaces. While the drop of a liquid, inside is liquid, outside is a medium, it has only the outside surface is the free surface. Second case, when the air drop or the air bubble is formed inside the liquid, so inside is a medium, outside is liquid, so it has only the one free surface, that is the inside. Again, the air bubble formed in a medium has the two free surfaces, while the drop of a liquid or the air bubble formed in a liquid has the one free surfaces. And due to that reason, the pressure difference for an air bubble is equal to 4S upon R, while in case of the drop of liquid or air bubble formed inside the liquid is 2S upon R. Clear this? Okay. Now we are interested to obtain this relation Pi minus Pu is equal to 2S upon R for the drop, and Pi minus Pu is equal to 4S upon R for an air bubble. For that purpose, here the two figures are shown. Figure A shows the drop of a liquid or air bubble in a liquid, while the figure B shows the air bubble formed in a medium. Right? The inside pressure is Pi, outside pressure is Pu in both cases for the bubble and also the drop. Again, as shown in figure A, drop of a liquid or the air bubble inside a liquid, and figure B, an air bubble are shown. Right? The inside pressure is Pi and outside pressure is Pu. And just we discussed about that, the inside pressure Pi is greater than the outside pressure Pu. Now, suppose the initial radius of drop and bubble is R. So, its surface area is A1 is equal to 4 pi R square. When the radius of drop or the bubble is small r, so its surface area A1 is equal to 4 pi R square. Now, due to the pressure difference, inside pressure is much more compared to the outside pressure. Therefore, due to the pressure difference Pi minus Pu, the radius is increased by delta R. So, radius is increased by delta R. Therefore, the new surface area of bubble or the drop A2 is equal to 4 pi into bracket new radius R plus delta R whole square. Again, due to the pressure difference, the radius is increased by delta R. Therefore, the new surface area of bubble or drop A2 is equal to 4 pi into bracket new radius R plus delta R whole square. We simplify this bracket 4 pi into bracket R square plus 2R delta R plus delta R square. Delta R square is the square of increase in radius that is very small compared to the other quantities. Here, delta R square is very small. We are neglecting the delta R square. Therefore, the new surface area A2 is equal to 4 pi R square plus 2R delta R. That is our equation number 2. Initial surface area is this. A1 is equal to 4 pi R square. Due to the pressure difference, radius increased by delta R. Therefore, the new surface area A2 is equal to 4 pi into bracket R square plus 2R delta R bracket on. Right? Okay. Therefore, the increase in surface area of bubble or the drop delta A is equal to final area minus initial. Therefore, 4 pi into bracket R square plus 2R delta R minus 4 pi R square. 4 pi R square is cancelled. Therefore, remaining is 4 pi into 2R delta R, 4 into 8 pi R delta R. There is the increase in area due to the pressure difference. Again, the increase in area due to the pressure difference is delta A is equal to 8 pi R delta R. Now, the work done for increase area by delta A is how much work is done to increase the area of double or of A bubble or the drop. Again, how much work done for increase the area of drop or the A bubble by delta A. So we know that from the definition of the surface tension, W is equal to surface tension into increase in area. Therefore, S into value of delta A, 8 pi R delta R. That is our one equation of the work. W is equal to S into 8 pi R delta R. Clear? Okay. Now, second our concept is that here the pressure difference, inside pressure is much more than the outside pressure. Inside pressure is much more than the outside pressure in case of the drop or the bubble. Pi, here the P. Therefore, Pi minus Po, this pressure difference or the additional pressure act on the surface of drop or the air bubble. This pressure is act on entire surface or the inside surface having the area is equal to 4 pi R square. We know that the pressure is equal to force per unit area. Therefore, force is equal to pressure into area. How much pressure is that? Pi minus Po. On how much area? 4 pi R square. So that much inside force is acting on the inside surface of a bubble or the drop. As a result, the surface of the drop is displaced by delta r distance. Displaced by delta r distance. That means we are going to obtain the another equation of the work done from the force into displacement equation. Right? How we obtain it? Now, due to the pressure difference Pi minus Pu, the force act on inside surface of area. Initial the radius is r, therefore area is 4 pi r square. This pressure difference Pi minus Pu is act perpendicular to the inside surface on entire surface. That means on area 4 pi r square. Therefore, force is equal to pressure difference into 4 pi r square act inside surface of bubble or the dough. As a result, what's happened? The surface is displaced by distance delta r. As a result, the surface is displaced by delta r. Hence, the work done is W is equal to force into displacement. Work done, W is equal to force into displacement. How much force act? Pressure difference into area. Area is 4 pi r square and pressure difference is Pi minus Pu. Therefore, Pi minus Pu into 4 pi r square. Due to this force, how much the surface is displaced by delta r distance, therefore into delta r. Again, the work done W is equal to force into displacement. How much force act? Pi minus Pu into 4 pi r square. As a result, the surface is displaced by delta r. Therefore, Pi minus Pu into 4 pi r square into delta r. That is our second equation of the work done. Already we obtained the work done is equal to surface tension into 8 pi r delta r. And here the work done W is equal to Pi minus Pu into 4 pi r square into delta r. Left hand side of both equations are same. Therefore, comparing these two equations 4 and 5. So we obtain Pi minus Pu into 4 pi r square delta r is equal to S into 8 pi r delta r. We are comparing the right hand side of equation 5 and 4. Equation 5 has the right hand side is Pi minus Pu into 4 pi r square into delta r is equal to S into 8 pi r delta r. Like this, delta r cancel, pi cancel, here 4, here 8, therefore 2. Therefore, Pi minus Pu is equal to 2S and r is remaining on left hand side, taken on right hand side. Therefore, Pi minus Pu is equal to 2S upon r. There is the pressure difference in case of drop of a liquid or the bubble formed inside a liquid, because it has the one free surface. Right? While in case of the air bubble formed in a medium, it has the two free surfaces. Therefore, pressure difference is written as Pi minus Pu is equal to 4S upon r. Due to the two surfaces, here the right hand side is multiplied by 2. Therefore, pressure difference Pi minus Pu is equal to 4S upon r. Clear? Very easy. Again we revise it. And that is the most important question frequently asked in all exam. Obtain the equation for axis pressure for the drop and air bubble. Or prove that Pi minus Pu is equal to 4S upon r for an air bubble. And Pi minus Pu is equal to 2S upon r for a liquid drop. How we obtain it? We do the two diagram, drop of liquid figure A and air bubble for in figure B. Okay. As shown in the figure A, drop of a liquid, that means the air bubble formed in a liquid and figure B and A bubble are shown. The inside pressure is Pi, outside pressure is Pu. The inside pressure is always more than the outside pressure Pu. Now, when the radius of the drop or the bubble is R, so its surface area is A1 is equal to 4 pi R square, equation 1. Right? Okay. Now, due to the pressure difference, inside pressure is more than the outside pressure, therefore the pressure difference is Pi minus Pu. Due to the pressure difference, the radius is increased by delta R. Therefore, the new surface area of bubble or the liquid is A2 is equal to 4 pi into bracket R plus delta R whole square. Now we simplify the bracket, so it's equal to 4 pi R square plus 2R delta R plus delta R square. Here the square of delta R is the square of increase in radius, that is very small. Therefore, we are neglecting delta R square. Therefore, the new surface area A2 is equal to 4 pi R square plus 2R delta R. That is the equation number 2. Therefore, the increase in area of bubble for the drop, delta A is equal to final area minus initial. Final area is 4 pi into bracket R square plus 2R delta R minus initial. Initial is 4 pi R square. So 4 pi R square is cancelled. Remaining is 4 pi into 2R delta R. Therefore, 8 pi R delta R is the increase in area due to the pressure difference. Now come the definition of the surface tension. Surface tension is work done per unit area. Therefore, work done is equal to surface tension into change in area. Therefore, the work done for increased area by delta A is W is equal to surface tension into delta A. Therefore, S into increase in area 8 pi R delta R. So this way we obtain the equation of the work done by the one method. Now the second method is that due to the pressure difference Pi minus Pu, the force act on inside surface of an air bubble or the liquid drop on area 4 pi R square is Pi minus Pu into 4 pi R square. Because the pressure is equal to force per unit area, therefore force is equal to pressure into area. Here the pressure act on inside surface of the air bubble is Pi minus Pu and area of the surface is 4 pi R square. So that force act on inside surface of a air bubble. Therefore the surface is displaced by this distance delta R. Under this force, the surface is displaced by delta R. Therefore, the work done force into displacement. Therefore, W is equal to force into displacement. How much force act? Pi minus Pu into 4 pi R square. And what is the displacement? Delta R. Thus, we obtain another equation of the work done, equation number 5. Comparing equation 4 and 5, right and left hand side are same. We are comparing the right hand side. Therefore, Pi minus Pu into 4 pi R square into delta R is equal to S into 8 pi R delta R. So here the delta R is cancelled, pi cancelled. Here 4, here 8, therefore 2. Therefore, Pi minus Pu is equal to 2S upon R. That is the equation of the pressure difference in case of the bubble in a liquid or the drop of a liquid. Because it has the one free surface. While the air bubble, it has the two free surface. Therefore, this equation is written as Pi minus Po is equal to force upon R. Clear? So that is very easy. Only keep in mind that first we have to obtain the increase in area, and using this concept of definition of surface tension, we calculate the work done. Second, the work done is obtained from the concept of the force into displacement. Due to the pressure difference, how much force is at Pi minus Po into 4 pi r square. Due to this force, the surface is displaced by delta r. Therefore, we are calculating the work done. Now we compare the both work done. We obtain the equation of the pressure difference Pi minus Po. Clear it? Okay.